Okay, so welcome to the Terminology Leading Practice stream of SNOMED CT Expo 2022. My name is Ian Green. I'm the Customer Relations Lead for Europe and also the Global Clinical Engagement Lead, and I'll be moderating today's session. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A box to type in your questions to the presenter, and for those on site, please use the microphone provided. I'm now pleased to introduce Tim Williams and Brian Carlsen from West Coast Informatics, who'll be presenting Less is More, a use case driven terminology implementation. So Tim and Brian, please proceed.
Thank you. As Ian said, my name is Tim Williams. I'm from West Coast Informatics. Brian Carlsen and I will be talking about our talk today about use case driven terminology implementation. I want to thank Sudha Swaminathan, who is not here with us, for her work on this as well. Next slide. There we go. So we wanted to take a look at how you could drive terminology implementation for specific use cases. And the use case that we chose for this talk was on COVID. So we went out and we tried to find different value sets and reference sets for COVID, both, diagnoses and signs and symptoms and procedures and vaccines and all the drugs and everything related to COVID, and see how we could affect the size of the terminology and kind of narrow that down and what benefits you could get from that. So if you look at SNOMED currently, SNOMED has about 350,000 concepts with millions and millions of relationships, and that number changes every release, which are now monthly. LOINC has with it over 98,000 codes with even more part codes that represent the different components of a LOINC code, the different axes of a LOINC code. RxNorm has over 110,000 active codes within it and millions of relationships as well that can be used to record medications in the US. ICD-10, the clinical modification in the US, has 70,000 codes, and CPT has over 10,000 codes. Next slide. Having a code for everything and having these large code sets is great, especially for large healthcare institutions who need lots of codes to represent all the things that they see in everyday care. But in a lot of cases, you don't need codes for things like water skiers injured from a cruise ship. That's probably something that doesn't happen very frequently. And being struck by a macaw is something that's probably definitely regional, unless you're working in a zoo or a pet store. But the bottom one there, I have 3 teenage boys. So it's definitely something, low personal hygiene is something that occurs quite frequently, especially on car trips. So next slide. So we took a look at COVID. COVID was definitely a fast moving situation, especially in the early parts of the pandemic, where new signs and symptoms were being recorded, in the first few months there. They weren't quite sure what was actually being related to COVID and what wasn't. There we go. Thank you. And you had different use cases for reporting COVID, for example, to public health departments. Was definitely something that applications could take advantage of terminology. The problem is, for public health reporting, you don't need all of SNOMED and all of LOINC to do that. You need just focused parts of SNOMED and LOINC. So having a quick deployment of terminology, a quick terminology server you can stand up where you have just the codes that you need. You don't have to go and search and filter by reference sets. All of that data is there for you is something that would help tremendously in future pandemics. Next slide. So with our use case, we actually took a much broader look at COVID from not just a public health reporting, but we looked at all of the possible use cases for COVID to see what that would relate to as far as size goes. Obviously, if you look at just a public health reporting use case, that's a much smaller set of data than what we have here. But we took SNOMED from 350,000 codes and then got it down to about 2,700 codes, which was quite a large reduction in the amount of SNOMED that you need just for COVID. LOINC including the part codes that represent the axis and LOINC, we got it down to about 3,500. So if you exclude the axes codes, it's probably even less than that. It's probably half of that number. RX norm is a much larger slice. We only were able to reduce it by about a half, and Brian will talk more about the reasons behind that. ICD-10 CM, 70,000 to 816, and CPT, we actually got it down to 241. In a lot of these cases, the value sets and the reference sets that we found to drive this, we actually found additional codes outside of that as a result of the review process. We were able to identify additional ICD-10 codes, for example, that weren't in the value sets that we found at for example, the National Library of Medicine's Value Set Authority Center. Next slide. So some of the benefits we found of having a use case driven terminology, and we've heard some of these similar use cases for use case driven terminology this week at the business meetings. For example, laboratory tests, they're going to start looking at how to model those within SNOMED, and they want to look at focused sets of LOINC codes, for example, or laboratory tests from different national release centers, so that they can focus in on just a smaller set of data and modeling that. So having smaller sets of data is good for, for example, search and retrieval. If I want to focus my search and retrieval of concepts within SNOMED, you can do that by just focusing on the use case itself. Having targeted sets of data in a single place for research or reporting, public health monitoring, streamlined patient cohorting, a rapid turnaround of content, not just within creating content, but also republishing reference sets and value sets as you look and find missing content. And then also collaborating between multiple organizations. Like I said, for the laboratory piece, having multiple national release centers send in what they're using, their most common codes are for laboratory observations is important to have a small set to do that. Next slide. So if we look at some of these benefits in depth. Next slide. There you go. Let's look at limiting search results. So a good example is fever within SNOMED. If I look at the SNOMED browser on the left-hand side, you see that searching for fever, looking and focusing on just findings and disorders, you get over 300 concepts within SNOMED as search results. So if you limit that for COVID and do the same search within our terminology server that we set up, you get 16 results. So obviously scrolling through and making sure you choose the right fever concept is much easier when you get a lot less results back and you've limited it to just the ones that you're interested in. Next slide. Similarly, if you're trying to choose content to populate fields with, you can do that by limiting the results. We actually have all of these concepts in our terminology server, but we could, if we wanted to, limit that to just public health reporting, which would be the positive qualifier value, negative detected and not detected qualifier values. But SNOMED also represents those as findings, which would be a combination of the test plus the result. And those you could also use, but depending on your use case, you would want to eliminate one versus the other. So you're only choosing the one that you actually need. Next slide. And as I said earlier, targeted sets of data, if you were looking at just reporting for public health, you could limit your sets of data to just the value sets of LOINC for ordered tests, just the value sets of LOINC for and SNOMED for test results. So the resulting test and the actual resulting value for that test as well. Patient demographics, you can limit that set of data as well. So limiting those targeted sets of data to just the use case even further than what we chose to do is something that would benefit. Next slide. Streamlined patient cohorting. You could easily find patients who've had long COVID and that were given certain treatments that are in your use case driven terminology. implementation, age, sex-related differences in outcomes and events. It's much easier to do that if you have a targeted set of data. You can do things like inferencing much faster over that smaller set versus the whole of the SNOMED. Next slide. Expanding content is a lot easier with a smaller set. If you have a targeted set of data, it's much easier to find gaps, and you can find things that are missing. And then you can go out to the broader SNOMED, broader LOINC, and so on, and try to find those codes if they are missing. And if not, you can create them much faster. So for example, long COVID was first reported in the spring of 2020, but it wasn't officially added to SNOMED until July 2021. And then something called COVID toes, which is a skin condition, a skin rash that's kind of been associated with COVID infections, is something that's still not available in SNOMED. So in that case, it's something you can request, or you could add it to an extension pretty easily if you have a much smaller set of data. Next slide. One of the other benefits, and I think this is one that's been talked about at the business meetings this week, is it's much easier to find incorrect content or quality assurance issues if you have a much smaller hierarchy that you need to browse over. So if you were looking at the clinical findings hierarchy within the current SNOMED browser, it's got probably 100 children underneath it. So by limiting the amount of concepts within the clinical findings hierarchy to just the ones that are there for a COVID use case, you can find issues. For example, the 4 concepts at the bottom, SARS-CoV-2 antibody test negative, positive, detected, not detected. Those are, if you look at similar concepts within SNOMED, they're all tucked underneath the evaluation finding hierarchy, which is where these 4 should be. So it's much easier to find those kinds of children that are in the wrong place by looking at smaller hierarchies and focusing on the concepts you're trying to find. Next slide. And obviously that goes into multiple organizations collaborating on content. If you have a much smaller set of content, it's easier to exchange that and work on it. If you're trying to test out something that is, for example, editing the body structure hierarchy, or editing drugs, the drug terminology, not having to deal with classifying all of SNOMED, it's much quicker if you have a much smaller set of data, and that can then be folded back in. So same thing here, if you have multiple organizations that want to share content and QA it and edit, it's much quicker if you have a smaller set of data to do that. Next slide. So I'll go quickly over our process of how we produce this COVID terminology server that we have deployed. And the first thing was we identified sources, and we looked at various sources. SNOMED has some great pages on how to code for SNOMED, and those are in the terminology server. We also looked at National Library of Medicine's Value Set Authority Center. We looked at AMA's website to find which CBT codes they recommended. LOINC's website had some good stuff as well. The Food and Drug Administration had a live in vitro diagnostic Excel spreadsheet that they produced that had all the COVID tests and all the test result values and specimen types and things like that. So we pulled all of that data in and created the terminology server. We then evaluated to see if we were missing anything. And then we either submitted it or added the missing content if it was already in SNOMED to the value sets, and maybe created our own value sets in those cases. And then we just iteratively went over this process until we got a terminology server that we were happy with. And obviously it's a never ending process. It's something you always have to continually refine and add things as new treatments come online and new tests are produced. Next slide. So unfortunately, we're not able to do a live demo, but Brian's going to talk about some of the screenshots. If you're interested, we have COVID terminology tools where you can actually go out and test drive this, and you can view the YouTube as well.
All right, thank you, Tim, for a good start here. Yep, you're encouraged to go investigate the tool for yourself. We put it up so people can play around with it, and made a demo video so you can kind of walk through how the tool works. So we'll go through a series of screenshots to look at some of the things that Tim was talking about, but I kind of want to take it back to the top for a second and say the thesis of this talk is less is more. This idea that you can have use cases that involve multiple terminologies, but you don't need all of them. And it actually improves efficiency and all of the other benefits that we discussed. So we're going to take a look at some specific examples now. So if we could go on. So this is just what it looks like when you go to the URLs, covid.terminology.tools. Let's go to the next one. Click the button to start browsing. All right. And then here along the top, you'll see all the terminologies that are loaded. So we have CPT, CVX, ICD-10, CM, LOINC, ArcStorm, and SNOMED CT. Were we to click on SNOMED CT here and open this ref sets accordion, you can see what gets loaded up in here. And so here are a few examples of the kind of things we were talking about. Each of these names in the middle is actually linked to the resource from which the content was derived. So we'll simulate clicking on this. We could go to the next slide. And this takes us to this Confluence page hosted by SNOMED that contains these definitions of various aspects of coding around the COVID use case. And this page is full of codes and of ECL expressions and other non-technical representation of the content. And so effectively what we're doing is saying one can take a spec like this and implement it so that it's available to tools, to user interfaces, and to downstream workflows. Let's go to the next one. If you click on one of these things in the tool, it loads the list of concepts that are involved, so you can kind of see what they are. And then you can click on one of these concepts and it'll load the report. So next slide will just show that. So it'll open a concept view in our browser that gives you information about the hierarchy and the descriptions and the relationships, and also all of the other ref sets that this concept might participate in. So there were data sources from a variety of different places, and many of these concepts are not just in a single thing. So the view from the top lets you kind of explore into a particular set. This lets you start with a concept and explore out to all of the sets that happen to contain that thing. Let's go to the next slide. So that was the example of SNOMED as an authority authoring a how to code to COVID document. Here we've got another example that, as Tim indicated earlier, comes from the NLM's Value Set Authority Center. There are many, many COVID subsets that have been defined and put into standards use in that tool that lists SNOMED concepts for various use cases. One of the really interesting things about this is you could imagine taking this whole thing a step further, where the tool actually leveraged the APIs of the VSAC system to allow you to sort of choose the subsets from which you wanted to build the terminology set, and then it would dynamically create exactly that. So rather than us going around and manually pulling a bunch of codes, which is how we started this, you could do it programmatically using something like the VSAC or something like the new RefSet tool that's being developed and deployed. Let's go to the next one. So another case Tim mentioned is like there are situations where we may want to add our own codes that are in none of the lists that we encountered. And this curated content list came from some work we had done with some customers who were interested in tracking things about COVID. And they had called out certain ArcStorm and SNOMED concepts. Here the ArcStorm is shown. So we've switched terminologies. And this is a demonstration of essentially the idea that you don't have to just stick with things that you pulled from somewhere else. You can also curate your own content and then kind of build out the ontology to encompass that and its supporting stuff. Let's look at the next one. And then, so here's a similar thing where, you know, we took, let's say, the SNOMED concepts that were listed, and then we computed the maps to the ICD-10 content on the other side and found codes that weren't actually specifically mentioned in any of the ICD-10 value sets. And so the idea there is you can actually augment and expand the data that you're working with to include computationally derived relevant things that are near the space in which we're operating. It's sort of, the plan is to take an input of some stuff that's brought together by humans who are interested in a certain set of content. And then from there, all manner of approaches can be used to compute out the larger supporting set and related set of things, but you can retain the provenance of where each thing came from and how it was computed. Let's go to the next one. And then finally, this is just an example. If you search for COVID toes, you'll find we popped in a couple of extension concepts in here just to show how that might look. And, you know, the point being, you can build an environment like this with your own extended content that isn't specifically in the standard yet, but maybe it's in a process of being developed and so on. Let's go to the next one. Okay, so that kind of brings us to the end. I think we can summarize by saying the goal of this approach is to say terminology can be less burdensome and easier to engage with if you only focus on the pieces of it that you're interested in and you don't try to use all of it at the same time. And that can speed up both things like content development, either within an organization or cross-organizationally, and kind of product development on top of those things for tools that are targeted in the use cases that they're trying to serve. Our focus as a company is entirely around making terminology easier to use right now. So that was kind of the point of this project, is to offer yet another way to lower the barrier to entries to getting involved in using terminologies. So you don't need to know everything about all the weird ways in which terminologies represent all their content. You can just work with the stuff you're interested in, learn about it, do things with it, and then kind of go from there. And finally, a plug to visit our booth at the expo. And please take some time and go to this tool yourself. You should be able to just get in and start playing around, and we'd be interested in any feedback that you have. Thank you.
So thank you, Brian and Tim. They'll now take your questions.
It did go up the hierarchy and grab additional parents.
And all the supporting content.
Yeah, and all the supporting content as well. And that's why it goes from smaller data sets to like 2,500 codes. The sub-ontology doesn't grab all of the parents, though. It does some. It eliminates some of the redundant primitive concepts that aren't needed. So I think it depends on your use case whether you would want to
Add them
have everything or not. So we actually did, as a result of that, go back and clean it up, because some of the top level hierarchies were even more than what we thought they should be. So we added a few more primitives into the list just to cover that.
And obviously we didn't use the SNOMED sub-ontology generator for ICD or ArcSnorm, but we used the UMLS and, at least followed the chain of things up to the root. So the hierarchy was there, but as you know, in ArcSnorm, there's no hierarchy. So that's why there's so many ArcSnorm concepts, because we follow the graph. So hydrocortisone was one of the ingredients. And if you follow that out, there's many, many components of many, many clinical drugs of different strengths. So we tried to say, don't just target the one thing, but also the surrounding content. So in the context of using that, you can understand what the model is and terminology and so on. Yeah.
Any further questions in the room?
Thank you. Hi. So at Early Tracks in Belgium, we are also trying to see if we can have use case based subsets and value sets, because as you said, there are many things that are not needed and it's easier when you focus. I was wondering, when you built your value sets, did you base it only on theoretical terminology point of view, or did you go to the actual actors in the field to see what they use every day, what they need?
Yeah, that's a good question. Okay, so I would say, we started by saying each of the core terminologies that we're using published something or many things that said these are sets of codes that are useful for this use case. So we kind of went broad and scraped content. Scraped is the wrong word, but found content that was specifically indicated by authorities around the space that it should be used. And for our own custom curated sets, those were basically driven by the use cases of specific projects that we worked on. Peter, we've got a
question here from before. No, there was a gentleman. Yes. Sorry.
Yes, I'm Serge from CTO at Bright.ai. I just have questions about the early slides that you had in regards to the curations from 350 to 5K in terms of selections of codes. Interesting to know what was the manpower involved into that process.
It was,
and the type of profile that you use for that selection criteria.
Yeah, so what we did was take a sets of concepts. Some of those SNOMED pages we were pointing at do have expressions in them, so we resolved the expressions and effectively wound up with a kind of master list. We attached the URLs to all of the things that they belong with. So there was an amount of human effort to kind of curate all the data sources and put it all together, but then the actual building of the terminologies and all that was done programmatically so that it could be easily recomputed. If we wanted to add a few concepts or take a few concepts out, we could just change the configuration of that and then rerun the whole thing and build it back up again.
Yeah, it depended on the source. Some of the sources were pretty easy. The value set authority is a list of codes. We use the FDA livid file, which was a live in vitro diagnostic test file. That was a little more difficult because you have to parse codes out of an Excel field. So it was, you have to scrape, I would call it
Actual scraping.
Yeah, actually scraping. So yeah, it depended on the source, how difficult it was to
Yeah.
get the codes.
I'm terribly sorry we are out of time. I need to give delegates 5 minutes to get to the next session as we are a little spread out today. So apologies to anyone who's not being able to ask their question, including those online. So thank you very much.
We'll
Tim.
happily answer any
Brian.
questions at our booth.